we're back. We're going to finish up just completing the square with this other example where we have to write y equals negative. There's a negative there. 2x squared plus 10x plus 1 in vertex form. And we can get it in vertex form by completing the square, right? So one thing to note is that if you are completing the square, you cannot have a coefficient on the x squared term. There cannot be an a. So in order to make that happen here, so I can complete the square, I'm going to factor out the negative 2. Okay, then this would have to be minus 5x. And then I'm just going to close the parentheses, and I'm going to leave the 1 outside of the parentheses for 2 reasons. 1, we need to do that anyways for completing the square. And 2, I don't want to factor out negative 2 from 1 and be left with some fraction. So that's how I'm going to set that up. Now I need to figure this out, which equals negative 5 over 2 squared, which then just comes out to, I'm going to write it as 25 over 4. Okay? So that is the thing that needs to be added and subtracted to the right side of the equation. So I am going to add 25 over 4 here, and I'm going to subtract 25 over 4 from this term. But here's the thing, I can't just subtract 25 over 4 because then I'm not adding 0. Here, when I'm adding 25 over 4, I'm really adding 25 over 4 times negative 2. So when I subtract, I need to subtract 25 over 4 times negative 2 as well, right? So that it balances out and there's 0. So that's something to remember. If you're factoring out a number so that you can complete the square, you need to make sure to incorporate it back in when you are adding and subtracting that value to your expression. Okay, so now let's keep going here. So what do I have now? I have y equals negative 2. And I'm going to have something squared in there. And then what's left out here? Let's just deal with all this first. Plus what? Well, this becomes 1 minus, and then it's negative 50 over 4. So I'm just dealing with all this right now, which then becomes 1 plus 50 over 4. Well, what's 50 over 4? It's 25, half of 25. Actually, I'm just going to leave it. No. Yeah. So I'm going to rewrite it like this. Just trying to think if I want to leave it a fraction or a decimal. So I'm going to write it like that, right? 50 over 4 is the same as 25 over 2. And then if I just add them, if I make that a fraction, then this whole thing comes out to 27 over 2, okay? So all of this arithmetic, adding and subtracting negative numbers, comes out to 27 over 2, which is a decimal, but I'm just going to leave it a fraction, okay? Now what goes in here? Well, I know my first term's an x. So it's x plus or minus something squared, and it's a perfect square, meaning when I square it, I'm going to end up with x squared minus 5x plus 25 over 4. Okay, so how do I do that? Well, what's going to go in here is minus 5 over 2, okay? Because that's what we squared. So let's check it. If I just work this out really quickly, this part, I would have x squared minus 5 over 2x minus 5 over 2x minus 5 over 2 squared becomes 25, positive 25 over 4, right? And then when I combine those, that becomes x squared minus 5x plus 25 over 4, which is exactly what I want it to be. It matches that. So just a little proof there. And then now, my equation is y equals negative 2. I'm just going to rewrite this again. I guess I didn't have to because it's all already simplified. If you wanted to write this in decimals, you can. But so I wrote it in vertex form, right? A x minus h plus k. So what is my vertex? It's h comma k, right? So here my vertex would be 5 over 2 comma 27 over 2, right? And you could graph it and check it with my calculator across the room, right? But these are giving you the same, this is the same parabola. Sorry, this and this. This is just different forms, different ways of writing the equation for the parabola. This one is just more convenient because you can pull the vertex right out from it by completing the square. All right, until next time.